GeopByte.
Look at the another important question asking like this. A particle is moving such that its position coordinates x comma y are 2 meters and 3 meters at t equal to 0. At t equal to 0, at t equal to 0, right? It is given initial position equal to 2 I cap plus 3 j cap, and at t equal to 2 seconds, at t equal to 2 seconds, the r bar equal to 6 I cap plus 7 j cap, which is in meters. And at t equal to 5 seconds, at t equal to 5 seconds, then position vector I can write as final position vector rf bar equal to 13 I cap plus 14 j cap, 14 j cap. It is also in meter. The average velocity, right, from time t equal to 0 to time t equal to 5. That's why I have considered this is the initial position vector. Initial position vector. This is the intermediate position vector, and this is the final position vector. Okay. Then then let us decide the displacement first, because average velocity equal displacement by time. Displacement r bar equal to rf bar minus ri bar. It is equal to rf bar is 13 I cap 13 I cap plus 14 j cap minus 2 I cap plus 3 j cap. It is equal to 13 minus 2, 11 I cap plus 11 j cap. That is the displacement. Then average velocity, average velocity VAVG equal to displacement by the time period, that is 5 seconds. Displacement is 11 I cap plus 11 j cap divided by 5. It is equal to 11 by 5. It is equal to 11 by 5 I cap plus j cap. That is the average velocity. Look at the option D. Option D is absolutely correct. Are you following clearly? Yes. Similarly, let us take the another important question asking like this. The displacement x in meters of a particle of mass m in kg moving in one dimension under the action of a force is related to time t. The time t is given in terms of x root x plus 3. The displacement of the particle when its velocity is 0. What is the displacement of the particle when velocity is 0? Right? Let me write that point. Displacement displacement equal to how much when velocity equal to 0. Okay. For that, this can be written as root x equal to t minus 3 or x equal to t minus 3 whole square. That's the displacement. Then velocity v equal to what? Dx by dt. It is d by dt into t minus 3 whole square. Simplify this part. It is equal to 2 into t minus 3 into 1. Okay, that is the velocity, right? Now let us decide the time when velocity is 0. If velocity is 0, means 2 into t minus 3 equal to 0, t minus 3 equal to 0, t equal to 3 seconds. That means after 3 seconds, the velocity is 0, right? Then let us decide the displacement x from this. Displacement x. T equal to how much? 3 minus 3 whole square. 3 minus 3 how much? 0. That means displacement is 0 after time t or when velocity is becoming 0. Understood clearly? Very easy problem. Okay. Look at the option. Option B. Option B is absolutely correct. Okay. Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, next 5 seconds and the next 5 seconds respectively. That means h1 is the vertical distance covered by the falling stone when the time t1 equal to 5 seconds. Next, h2 be the vertical distance traveled by the same stone in the another 5 seconds means t2 equal to 10 seconds. Next, h3 be the distance traveled by the same stone in the other 5 seconds means t3 equal to 5 plus 5 plus 5, that is equal to 15 seconds. Okay, here it is 5 seconds plus 5 seconds equal to 10 seconds. We are asked to decide the relation between h1, h2 and h3 is. Okay. For that, for a freely falling body, for a freely falling body, h equal to ut plus half gt square. For a freely falling body, initial velocity u equal to 0. From this, I can write that h equal to half gt square. Okay. Then, h1 equal to what? Half into g t1 square. It is equal to half into g value 10. 5 square means 5 into 5. It is equal to 2 5 times 5 5 25. 25 into 5 125 meters. Okay. The vertical distance traveled by the stone in the other 5 seconds means h1 plus h2 equal to half into g into t2 square. It is equal to half into g value 10. T2 is 10 into 10, 10 square. Okay. Now here 2, 5 times. It is 5 plus 10, 5 into 10, 50. 50 into 10, 500 meters. From this H2 equal to 500 minus H1, it is equal to 500 minus 125 is equal to 375 meters. Okay, understood clearly? Yes, similarly, in the other 5 seconds, that is H1 plus H2 plus H3 equal to half into G into T3 square, half into G value 10. Here T3 is 15 into 15. Okay, simplify. Here it is 2 5 times. 5 into 15, 75. 75 into 15. 75 into 15. 25, 37, 75. Here it is 5, 12, 10. H1 plus H2 plus H3 is equal to 1025. Then H3 equal to 1025 minus H1 plus H2. It is equal to 1025 minus H1 plus H2 is 500. Here it is, no? 1 minute. Here it is 11. This is 11. 1 minute. You should be very careful. This is 11. 11. 11. 11. 1125 minus 500. It is equal to 625 meters. Then H1 is to H2 is to H3 is equal to 125 is to 375 is to 625. 625. Then H2 by H1. Let me write the H2 by H1. H2 375 by 125. It is equal to 3. H3 by H1. 625 divided by 125 equal to 5. Then finally H1 is to H2 is to H3 equal to 1 is to 1 is to 3 is to 5. 3 is to 5. That is the answer. Look at the options. Right? H1, H2 equal to 3 H1, H3 equal to otherwise H1 equal to H2 by 3. H1 equal to H2 by 3, correct. And H1 equal to H3 by 5. H1 equal to H3 by 5. Yes, option B is absolutely correct. Okay, from this I can write it. Here H2 equal to H1 equal to H2 by 3 and H1 equal to H3 by 5. So what is written? H1, right, is to H2 by 3, H2 by 3 and H3 by 5. H3 by 5. Understood clearly? Yes.
GeopByte.